Good afternoon. Welcome for joining us. I still see people being admitted, so we want to give people a few more seconds, but we can go ahead. We will plan to start at 2:02. We will officially start the webinar at 2:02, just to give all of our attendees who have joined us today an opportunity to enter. I will start. You are entering our webinar today, a jointly sponsored APPAM and ASDA Academic Data Science Alliance webinar. The title today is the Responsible Data Science for Positive Social Solutions and Impact. And the purpose for this webinar, APPAM and ASDA, some of our members. I'm Frances Carter Johnson. I am the co-chair or lead for the APPAM data science community. And we met with ATSA several times, and we realized that while data science is very important, we also want to think about data science for social good and positive social impact. So we are data science, artificial intelligence, machine learning are extremely hot topics. They're simultaneously generating both excitement and fear for United States citizens and beyond. And so these two groups, the Academic Data Science Alliance and the Association for Public Policy Analysis and Management, designed this webinar to expand examples of how data science can be used for good and to improve both the identification and implementation of public policy problems. So again, I'm Frances Carter Johnson. We will move on next to my co-chair for the webinar, who will discuss logistics with you.
Hi, everyone. Thank you, Frances, and thank you all for joining. I'm Michaela Parker, founder and executive director of the Academic Data Science Alliance, and I just wanted to cover a few points before we get started. One is that this webinar, as all of the webinars that ADSA takes part in, is governed by our code of conduct. So I encourage you to check that out. It's on our website in the footer. And this, if you hadn't noticed when you joined, this webinar is being recorded. So please mute your microphone when you're not speaking. But we do want to encourage questions. And so if you have questions, even while a panelist is speaking, please go ahead and utilize the chat function of Zoom to ask your questions there. We also encourage you to share resources. Anything relevant to the topic of conversation is really welcome and helps everyone learn and grow in this environment. So now I think I'm going to turn it back to Frances.
I muted myself. I was not speaking. Excuse me. Frances Carter Johnson. I currently work at the National Science Foundation in the Directorate for STEM Education and in the Division of Equity for Excellence in STEM as an education data scientist. My backgrounds include physics, engineering, and a terminal degree in public policy. And I really work at the intersection of evaluation and data analytics for the National Science Foundation. I've been a member of APPAM since graduate school over 10 years ago and really enjoy the APPAM community, and more recently became co-chair of the data science community for APPAM.
And I'm Michaela Parker, and as I mentioned, I am founder and executive director of the Academic Data Science Alliance, and I'll tell you more about our organization in a minute, but I'll also just note that previously I was one of the executive directors, co-executive director with Sarah Stone at the University of Washington eScience Institute, where I helped to launch a data science for social good program, which I think is now in its 10th year or something close to it. So very proud of that work and love the intersection with the mission and values of my current organization, ADSA, and of course with this panel and this webinar. Next slide, please.
Michaela and I are your moderators for the...
Yeah, we didn't say that, did we? Next slide. There we go. So just a little bit about our organization. We're fairly new. We launched in 2019. We're a professional association for data science in academia. So data science initiatives, degree programs, etc. We are also a community of data science leaders, practitioners, and educators who believe in a just and equitable future where data science approaches are thoughtfully applied in all domains for the benefit of all. I just noticed now our URL is not on here, but if you want to learn more about us, you can visit academicdatascience.org. There's also a QR code on this slide that will take you to our website where you can learn all about the events that we run, resources we build, and of course, how to get involved with our organization. And now on to Francis.
I've mentioned the APPAM data science community. Briefly, this is a community, one of several communities within APPAM's organization, but the data science community explores data science topics and applications in public policy and management, and it takes a broad view of data science, including quantitative skills, domain expertise, ethics, and communication. The community has only been established about a year, and it's looking to grow. So if you would like more information, feel free to go to appam.org and go to communities, and you can choose the data science community and other communities as well. And now I'll pass it over to Michaela.
Yes. Well, I think you were going to say what I would say, which is we're honored now to introduce our panelists. And rather than read their bios off a page, we thought it would be much better for them to use their own words. So we're going to now invite our panelists to introduce themselves very briefly, because we'll get into questions that will dive into your research and program journey. But at this time, let's stick with name, affiliation, and something brief about your educational background and current work. And we will go in alphabetical order by last name, which means Dharma Daly is first.
Hi, good morning from Seattle, or good afternoon elsewhere in the country. I'm so happy to join you today. I'm a research associate here at eScience Institute, which is an institute that supports data science discovery across the university. I also teach aspiring engineers at UW-Bothell human-centered design. My background is a BS in interdisciplinary studies from SUNY Empire State College and a master's and PhD in human-centered design and engineering here from the University of Washington.
Great, thank you. Greg, you're next.
Hi, everybody. Really excited to be here. My name is Greg Dobler. I'm an associate professor at the Biden School of Public Policy and Administration at the University of Delaware. I'm an urban data scientist. I use and develop machine learning techniques and AI to study cities, and in particular, the complex interactions between the human-built and natural environments in cities and how that intersects public policy. I also run our urban analytics and policy program here at the Biden School, as well as our urban data science certificate program. So if there's any students on the call who are interested in some of this stuff, drop me a line.
Fantastic. Nothing wrong with a shameless plug. Okay, we're on to Jamal. Please take the stage.
Indeed. Good afternoon and good morning for those on the West Coast. I'm Jamal Green, assistant professor in the Department of City and Regional Planning at the Weitzman School of Design at the University of Pennsylvania. In terms of background, I have my bachelor's in economics and master's in planning from University of North Carolina, Chapel Hill, and I got my doctorate at Portland State University in urban studies. And pleasure to be here. Thank you.
Great, thank you so much and welcome. Mirsad.
My name is Mirsad Hadjikadic, and I'm currently in Bosnia. I'm at the University of North Carolina at Charlotte in the College of Computing and Informatics. Used to be the dean of the college. I used to be a person who started the Data Science Initiative, and now that is a School of Data Science in the College of Computing and Informatics. I'm a professor there and a professor in the Software and Information Systems Department, research area, Machine Learning AI, Complex Systems Institute, Complex Systems. But I also have a degree in public policy, public administration, as well as computer science. And my touch point with policy is that I ran for president of Bosnia-Herzegovina at some point.
Wow, and I did not know you were in Bosnia right now, so that's quite the time difference. We appreciate you being here. And last but not least, Esteban.
Say it's hard to beat that. I haven't run for election. But hi everyone, my name is Esteban Quiñones. Good morning, good afternoon, and I guess good evening to some of us. I'm a researcher at Mathematica. Mathematica is a private, let's say, policy research firm, and I work in the global unit. Most of my work is focused on evaluations of different types of policies, either in the international development or sometimes in the climate change space as well. And most of my background really is rooted in economics, though I also have some training in demography as well.
Excellent. Thank you all for joining. I believe Francis will take it from here.
Thank you all. We will now begin the questions that we have for the panelists. So thank you for your introductions and telling us a little bit about yourselves. Can you please share briefly how you became interested in programming and/or research at the intersections of data science, projects for social good, and public policy? And we will start with Dharma and continue in alphabetical order by last name that we did for introductions, but that's okay.
Well, so my path is a little bit circuitous. My background actually is in grassroots work around community media and then the internet, going back to the 1990s when I got really passionate about ways to encourage civic, economic, and cultural participation within communities that were underserved by the media systems that existed back then. And that led grassroots work and grassroots project work led to policy advocacy, which led me to research, which eventually led me to grad school. The last project I did before I went to graduate school in 2010 was the largest, to that point, largest qualitative study on barriers to broadband adoption for low-income communities in the US, which was commissioned by the Federal Communications Commission to inform the US National Broadband Plan. And the study was really well received, but it was also just really made it clear to me how very infrequently user research was being used to inform the design of our communication systems. So that propelled me into graduate school, so I could get around other people that were doing user research and get some thinking about how to integrate this into our decision-making processes around these issues. In graduate school, I focused on crisis informatics, so looking at the role of social media in crisis-affected communities, which is the focus of that work throughout my grad school tenure. And that enabled me to look at use the sort of qualitative and participatory methods that I had before, but adding in big data kind of analytics, computationally assisted analytics to look at large social media data sets. And in graduate school, in 2017, I was approached by East Science Institute to be the human-centered design mentor within the Data Science for Social Good program that Michaela referenced. It is in its 10th year. We've now had 31 projects with 44 subject matter experts across a range of fields, from transportation to disaster response to human services, public health, a whole range of projects. And subject matter experts in this program are also the project leads, which makes it an interesting model. We've had 133 highly capable fellows working alongside these subject matter experts, as well as 19 academic data scientists that are employed here at the Institute. So my role in this is really a hands-on role with each of these projects, helping them to think about the ethics of their projects, shape the ethical perspective of the team, and engage with stakeholders in meaningful ways, which might surprise people, but it is actually really helpful even in the midst of very, very data intensive work for teams to engage with stakeholders in different ways that are meaningful for the project. And then most recently, I've also gotten involved with program evaluation of other eScience programs, which has even broadened out my perspective a little bit more on how scientists do data science across a variety of disciplines.
All right, I think I'm up next. I also had a very non-traditional path through academia. My long ago degree, my PhD was in physics, and I was a practicing astrophysicist for about 10 years before deciding to take a 90-degree turn in my sort of academic trajectory to start studying cities back in 2013. There were a number of reasons I decided to do that. One of the biggest ones that's very relevant to this discussion is that I wanted to do work that had it had a positive impact on people's lives, right, and people's quality of life. And the way I like to joke about it is, I had these sort of like I wanted to use my analytic superpowers for the forces of good as opposed to the forces of neutral. So I sort of stepped away from astronomy and moved into studying cities. I joined a center that was just starting up at NYU at the time called the Center for Urban Science and Progress, where I developed a facility called the Urban Observatory, which uses sort of proximal remote sensing techniques to study changes in the city on short timescales. And that sort of process led to a lot of sort of co-work with different city agencies, solving problems and things, Department of Parks and Recreation, Department of Transportation, Department of Sanitation, and so on. Also developed some collaborations with nonprofits that were interested in things like lighting policy, like the New York City Audubon Bird Conservancy. So, and then back in 2019, at the University of Delaware, the Data Science Institute there was just starting up, and so I came down to the University of Delaware as part of that and joined the Biden School then. And so yeah, so my path was sort of from the analytic side, sort of pulling over into the policy side, because that's where a lot of my work intersected after I sort of moved away from astrophysics, though I still write papers in physics from time to time. But as I sort of moved away from that, a lot of the work that I was doing involved sort of discussions and problem solving with public sector folks and nonprofit sector folks that related to policy and quality of life and sustainability and environmental impacts of things like air quality and vegetation health and transportation safety and so on and so forth. So yeah, that's how I got here. Was if you had asked me, do you think this is where you'd be, 15 years ago or right after I got outside of my PhD, I would have definitely not have anticipated that this was where I'd wind up in life, but I'm very happy to be here.
Indeed. So I'm a planner and geographer by training. And in particular, I identify as an equity planner, so a lot of my work, if not directly exploring, is informed, by a notion of trying to attack or interrogate inequality and the ways in which we kind of structure and manage our built environment can either like inhibit or exacerbate that. Um, and as such, my doctoral dissertation was focused on industrial land use, actually, and the role of jobs, because I was very concerned about the question of like, where are good jobs, and where are they available? And certainly at the time of the dissertation, industrial work, including manufacturing, was still kind of like the primary set of industries where people who did not have an advanced degree could still be able to make a good career, have benefits, pay, and advancement compared to the service sector. But in part of exploring that question, I had to be able to collect all of this land use data. I had to be able to get multiple forms of jobs data, right? And like all of these things required, kind of like more intensive co computational skills. Um, I'd already been building those up in my coursework and in my research assistantship work. But my dissertation process really was the thing that kind of solidified to me, I think, the benefits and power of of more sophisticated uh, more sophisticated computational approaches. And then after that, I actually worked for the state of Oregon in the Department of Human Services for an organization called ORAE, or the Office of Research, Reporting, and Implementation, actually as a staff analyst in data science. And then there I really got to see kind of like agency-oriented applied research and data science projects. And those experiences have really kind of like fundamentally shaped my viewpoint on the advantages, risks, and pitfalls of kind of like civic-oriented data science or computational social science, around kind of areas of public policy and urban planning. So that's kind of like my motivation going in. Excuse me.
Start, you're muted. You are up next.
Okay, it's my turn. I still don't know what I want to be when I grow up. I'm interested in everything, absolutely everything. I went to computer science college in Yugoslavia then, simply because that's where good students were supposed to go. Since then, I realized that it's a great tool to analyze and touch everything. And at the same time, I was interested in philosophy, religion, social sciences, how society works. Data about those activities will give you some sense of what people do and how people act. And I decided to try to do exactly that, figure out how do you quantify some of those areas that are not quantified or have not been quantified, or used quantification as opposed to qualitative approach to understanding the world around ourselves. I started looking at technology and how it contributes to the society. I thought it was going to unite us, but it divides us even further. People look for people who think like themselves. That's why I got into politics. I thought that politics touches everything about a society, every aspect of it, from economy to healthcare to education. And in my research and in my career path, I decided to really try to understand how and in what way can we build better societies. I'm interested in using technology for good of all of us. But it's not just machine learning, it's not just data science. I also use complex adaptive systems, agent-based modeling to see societies in motion. So we analyzed certain countries in the world and tried to suggest actions in terms of how to improve the well-being of the citizens in those countries in any way. Computers, artificial intelligence, data science, machine learning, genetic algorithms, AI, anything and everything, all of it interests me. In the end, all of them depend on the data that we produce. Who we are is captured in the data set that simply reveals how we act in the world. And I believe and I hope that the technology can help us make it a better place. So I am interested in figuring out how this particular set of technologies can contribute to making the world a better place.
And I can jump in now, going last here. This is Esteban. I think my origin story, begins before I'm aware of it. So I grew up in Miami, and most of my family is from and still lives in Ecuador. And from a young age, I had this sort of inkling that there was, something really deeply important about the inequality that I saw both growing up in Miami, but also when I was going back to visit family in Ecuador. And of course, I couldn't have, put my finger on the word inequality or sort of some of the concepts that were driving me. But I knew that I, wanted to work, to, let's say, rid the world of this type of stark inequality. And I ended up studying economics, I think, because of the sort of salience of the trade-offs that exist in how economic thought is taught, as well as some of the methodological, let's say, advancements and advantages that are associated with that particular social science. But at that point, I went and spent a few years with AmeriCorps working on community, in a sense, different types of community development projects within the National Civilian Community Corps. And although I really enjoyed sort of the more tangible nature of the community work, I also had this sense that I wanted to work on a policy level. And so, with that, I was studying actually more sort of, let's say, management of international development programs and thinking of going in that direction. But I took a course with a professor who was teaching an evaluation course, and it sort of, just captured captured my imagination in a way that then sent me on a different trajectory. And since then, I think I've been using, whether it's quantitative or qualitative methods, but thinking really carefully about how we code things, how we quantify them, how we categorize them, and trying to use that information to make the world in a sense a better place. And a big part of my work during the PhD was, focused somewhat on migration and development, but I realized that part of what I wanted to study was understanding how extreme heat and different types of climate shocks affect the agricultural outcomes of households. And this study in particular was in Mexico, and that how those shocks and those household experiences actually change the migration decisions of households in these rural communities. And that sort of opened a whole new fold for me in terms of realizing that I needed to understand and process and then analyze climate data in addition to socioeconomic data, in a altogether different way than I had conceived of things. And that's sort of how I think I've ended up on this trajectory. So I'll stop there.
Great, thank you so much. I'm actually going to mix it up a little bit and not go in alphabetical order, so I keep you on your toes. Because this next question, I want to spin off of something Jamal said about the pitfalls of working at the intersection of data science and civic work. To all of you, but Jamal, why don't you go ahead and start? What are some of the biggest ethical or institutional or legal challenges of doing this kind of work at this intersection?
Uh, for an academic level or as a public employee?
You choose.
Um, okay, well, I think at an academic level, as a planner, like sitting on a panel with other people who do urban oriented work, I think part of it is a data availability issue and a data quality issue are kind of two very big things that we have to think about, especially in planning. The census is still our primary data source for a lot of the work that we do. But there are many questions that census data cannot answer, or we just don't have the kind of granularity that's there. And, a lot of people within planning departments who are trained as planners don't necessarily have a lot of experience in being able to grab that kind of information or really know how to work with it. So I think that's one potential pitfall specific to planning. I think relatedly, I think another issue that pops up around planning, but I think other oriented issues with certain disciplines the is the domination of voices who have strong technical skills but very little substantive domain knowledge. And, this is where kind of like method in particular, I think, kind of like predictive analytics in particular is raised up to like an elevated level by those practitioners as opposed to people who have, like actual domain knowledge or theoretical understandings of the problems at hand. Um, to be able to move forward, right? And that's not to say that we don't need very good technicians, but it is worrying to me in looking at, say, the rise of smart city offices in many cities across the country. And many of those offices are engaging, in questions that are already kind of like well explored in in public administration and urban planning and in some other allied fields. But when you look at the people who work there, none of those people have that kind of training or exposure. And I worry about, how do you as like a staff planner who's not necessarily directly connected to the mayor's office or the governor's office, like how do you come in and be able to make an argument by folks who are able, to say, well, we have these models, we have these dashboards, we have these we have these visualizations, and you're coming in saying, well, yes, you do, but this is what kind of like 100 years of work in theory has kind of like led us to believe, and also empirical investigation. Um, so I think those are kind of like big issues that we need to be thinking about. And also on the academic end, I think as computational or quantitative researchers, I think being I think we need to spend more time with our data in terms of really trying to come to a better understanding of what does our data represent? What does it not represent? What is missing? And what are the logics that help to produce it? And in the ways that we're using it, like are we reproducing potentially, kind of like negative negative institutional actions, right? I think we see this a lot in spaces around like predictive policing and things like that. There's like all kinds of now I think kind of like well-known arguments around I think the weaknesses of those kinds of models. And frankly, like the racist assumptions, which end up underpinning a lot of them. But these things continue to be they continue to be reproduced and pushed, and I think this is something that the field and as academicians and teachers, we should be concerned about.
That is great. I think you actually touched on every single one of the other panelists' expertise. You really queued us up for this discussion. So thank you for that. And I'm going to go in from what I heard, maybe a little bit in reverse order, touching on what you just said with taking time with our data and really understanding what we can do with that. Esteban, you mentioned how we use data and quantify it. I think this is a good opportunity for you to jump in here. And just as a reminder, the question is, what are some of the biggest ethical, institutional, or legal challenges?
Yeah, thanks for that. I'm happy to jump in. A lot of what Jamal was saying certainly resonates for me. One element that is often missing, and that it's easy to sort of run without, let's say, enough of is truly its context, right? And it's really understanding context well. And there's a quotation by Ronald Coase that I always come back to, and it's data can't speak for itself. It's up to you to give it voice. Try to speak truthfully, try to speak truthfully. And I mean, I use that to remind myself because we collect vast amounts of data. We have an objective that we're, whether it's a hypothesis or a client that we're doing an evaluation for, or some element. And we sort of know in a lot of ways what we think might be the end goal. We're often trying to get to it pretty quickly in reality, right? Time is limited, resources are limited, and in all reality, we would be best off taking a step back most of the time. And that's not always possible, but it's something that I like to remind myself about. So, I see it less necessarily as institutional or legal, but to me, it really does come back to sort of these contextual and ethical aspects of, what role are we here to play? And so am I doing this work in service of my career? Am I doing it in service of a population, one that perhaps is more vulnerable and doesn't have voice? Things of that sort, that in the day to day, I think it's easy to forget sometimes. I know I forget, and so it's easy for those things to get lost. So that's often where I come down and try to sort of remind myself and reiterate for others the importance of those elements.
That's great. Awesome. And another thing also was mentioned was smart cities, which means I'm turning to Greg, obviously. Greg, why don't you jump in here on the biggest ethical, institutional, or legal challenges?
Yeah, so happy to do so. This is an obviously fantastically important question, and it's so, as I was thinking through this question beforehand, I mean, it's so vast. There are so many things uh, that relate to ethical standards, what ethical standards means, morality, and so on. With respect to the question of sort of data science, machine learning, AI, all that in public life, and the way that intersects with some of these. I mean, where to even begin? Let me say that I agree. I agree very much with everything Jamal said, and that is especially the uh, uh, to use uh, to use the Esteban's words, this context thing, right? So data science is like computation with context, right? And without that context, without that understanding, without that sort of discussion between sort of technical side of folks and sort of folks who are, who live it and have that domain expertise, without a meeting of the minds there, then in one case you're just sort of crunching numbers doing nothing. And then in the other case, you might not be able to sort of maximally use the data that you do have. So like that meeting of the minds is really important. But I want to highlight two things. I'll also talk about a practice and a training example. I want to highlight two things that I think are sort of perhaps the most important ethical problems here. And one is the impacts of this kind of work on marginalized and targeted communities, right? So there's a lot of, and some of the examples of this Jamal alluded to and discussed earlier, there's a lot of like building models for things, and those models can be put to either intentional or unintentional ill use, and that can have vastly disproportionate impacts on marginalized populations, underserved populations, and targeted populations. So as technologies develop, as new technologies are rolled out into and intersect with public life in the way that policymakers think about that, without sort of keeping that directly in mind at all times, that's really dangerous. And there's been a lot of discourse in the academic sector and just generally out there in the world, by people like Deb Raji, Tim McGebru, Joy Buolamwini, who have done a lot of work on these kinds of issues. That's very foundational. And then the other thing I'll say is from an academic point of view, I think one of the biggest ethical things that academia needs to be thinking about is that sort of systematic exclusion of certain people from STEM education, and STEM adjacent fields. I think there is, especially data science and policy, sort of offers a place where at this intersection between like sort of social impact, social sciences, natural and computational sciences, engineering sciences, things like that, where there's a lot of opportunity for growth and inclusion, and representation. And having seen the history of STEM and STEM adjacent fields and the way that it excludes folks based on things like socioeconomic status, and especially people of color, this is one of the biggest ethical quandaries in data science and public policy that I'm aware of.
Yeah, absolutely. Thank you so much for that, Greg. And I wonder, Dharma, if you can jump in here and kind of address that importance of the team players in data science and the importance of stakeholders.
Yeah, I sure could talk about that. The first thing though that comes to mind is the question, and I do have a couple of challenges that I'll throw out there and talk about the stakeholder part in a little bit. One of the things that really keeps me up at night is how the very well-intended actions that we're doing to go out and collect really comprehensive and accurate data that is persistent about underserved communities, for example, is that these infrastructures, as Sophia Noble, the data ethicist, talks about, anything that we have to assume that anything that can be done with these infrastructures will be done with them. And I don't think we have a good solution for that. So the things that we're doing, we're the good guys, we're out there collecting, doing all this work to understand certain populations, one policy change or one hack away from potential harms coming to those very populations. And I don't know of any good solutions for that at this point. So I think everything also, I agree with everything that the other panelists said as well. And I think one of the dimensions of equity that I think about as well is the vast disparity that there is within the policymaking apparatuses in the US itself. So from one city to the next, one municipality or county to the next, the ability to leverage these kind of analytic tools is really vastly different. So I think that's another dimension of these that in the US really has some profound consequences for how communities view themselves and understand themselves, and who gets to be doing the learning and leverage the learning and have ownership over the learning that we do. So I think that's something there. And to the point of to Jamal's point, and some of a perspective on really things that have already been said, but one informant talked to me about eScience being data bullies. So I was talking to somebody explaining what we were doing at eScience, and this person who's in the humanitarian sector said, "Oh, we call you the data bullies." So I worry about us being perceived as data bullies because either we're pushing people to collect data in ways that make them uncomfortable, which is an increasing issue. Everybody's out there. If you buy a carton of milk, people are asking for data about that purchase from you, or collecting it. And I think that anything we're trying to do with good is happening around this background noise floor of everybody else also asking for data. And so there's this element of perhaps bulliness that can come into it. And that also plays out on the analytics side, right? So one of the things that's happened in Washington State recently is there's been a move in state government, which I think is really great, to adopt different poverty measures that require multivariate analysis and are the recommended poverty measures for everybody that works on anti-poverty. For the last 40 years, they're the recommendations. But there's blowback among the analysts in Washington State, the everyday analysts in government who have to work with these numbers, and they're frustrated. They don't see the value of adopting these kinds of methods. And so I think when I think about, so wrapping it back to one element of stakeholder engagement is, how well are we supporting the everyday analysts with these technologies to feel comfortable and motivated and on board to work with this with this kind of science in a way that feels appropriate to them. And I'll leave it with that for now.
Thank you so much. And I think that cues up Mirsad really well, talking about citizenry and society at a higher level. Mirsad, why don't you drop in? Biggest ethical, institutional, or legal challenges?
Sure, there are three aspects that I can think of at this point. Let me start with universities, actually, because I spent a lot of time on interdisciplinary research and I was an administrator. And universities and institutions don't do interdisciplinary, transdisciplinary well. Life is holistic. Institutions are not. And looking at the data, and I had projects working with people from 7, 8 other disciplines. We use different vocabulary. We look at data differently. We collect different data sets. Universities don't support, institutions don't support those type of activities well. In terms of politics, society, ethical versus established practices, for example. Talking about politics, especially in developing countries, you talk about corruption on a big scale. Data, there's nothing ethical about it that people in power are interested in except for staying in power. Policies are there to be understood how to allow them to stay in power. You can collect data all you want, but if they control processes, then you are really stuck. So in such societies, the question of ethics is looked upon very differently. It is also a question of culture or values, and they change over time. The United States today is not the same United States as 20 years ago. Values today are different than before. So we talk about ethics within the context of those values, and we collect data on our practices in the time that we want to do research, not just our own time. And the third issue is the issue of truth. Whose truth are we talking about? All in the context of data that we collect, results that we gain, and policies that we establish. I used to work at a hospital as well. And there's a patient on the one hand, and there's a business that's providing care on the other. You don't always do what is ultimately the best. You do what is fine for the patient, but not what is ultimately the best because it's too expensive. So how do I look at the data? From which perspective? Which hat do I wear? How do institutions respond to that? Why are they there? To make money, and yes, but also to provide societal value, to offer the value to the society. So I think we have many issues to deal with when it comes to data science on the legal, institutional organization side, legal side, ethical side. We cannot assume that there is one absolute truth, one context. It is all a matter of perspective. And when you design system, the question is, whose perspective are we propagating?
Excellent points. Thank you so much. And thank you all panelists. We were or are running a little bit behind. So just to give you, the panelists, a heads up that Frances and I have combined the next two questions into one. If you have pre-prepared, she'll now continue with this next question, which is also a combination of the next two. So Frances, over to you.
So you all led into the questions very well with a lot of your responses. This next question, and if you don't mind, I'd like for Esteban to start to answer this next question. What are effective ways of preparing practitioners, including skills and competencies in training in this field of data science for social good? Specifically, Esteban, you followed up on Jamal's point about it would help us if we spent a lot more time with the data. We would solve a lot of our problems if at the front end we spent more time with the data. So if you could answer effective ways of preparing and really preparing analysts, students to spend more time with the data. How do we do that effectively, but also efficiently?
Thanks. No, that's a great question. Not an easy one. In that there's so many different ways to take this. I do think that something that I touched on before is relevant here, and it's that we're often quite time bound when we finally have the data that we're interested in, and so something that I probably reminisce about was when I was at some point doing data work for someone else. And while yes, there was a deadline, I could sort of just pour myself into that data and spend time getting to know it and sort of slicing and dicing it in ways that may not have seemed obvious as the right way to go, but really learning by doing, in a sense, for me was critical. And I think that that's true both in terms of knowing what we're doing with the data, but also to know the data itself. I do think that has changed over time, at least since let's say I'll date myself and the many moons that have passed since I was a student, and there's a lot more hands-on data work, whether it's in courses or in research support. And I think that, in all honesty, we could push that even further and in a sense expose our younger generations. In my case, it's my kids. My one of my kids what is in middle school, and he not that long ago was programming some songs in Python through something that was set up through his school, right? And it's kind of like blows your mind to think about, well, I hadn't even thought of how that would even be possible at that point in my life. So I do think that giving people the opportunities to really immerse themselves both in coding and in data, and doing these operations so they can learn, what works, what doesn't, and what does the data really represent. And as other folks have said, right, there are multiple perspectives. It's not that there's only one truth. And so being able to sort of appreciate those elements, I think that's the best thing we can do to really help people prepare for working with this type of data and doing data science for good.
I'll take a slight swerve and speak to ask the question from Dharma's perspective. You mentioned the analyst and analysts giving pushback to requiring multivariate analysis in poverty measures in the state of Washington. And this is an issue we deal with a little bit at the National Science Foundation. We have analysts who are dealing with the data on a regular basis. What do you think are effective ways of upskilling or preparing analysts as practitioners?
Yeah, so I think, but two ways we can think about it as a learning and skilling up kind of thing, but we can also think about it as changing people's work, right? Changing how they do their jobs and so I think there's another kind of analysis around not just, oh, we need to convince people that are not yet convinced that multivariate analysis is good, but also, how does it change the work that they do and resourcing them in those ways, and maybe changing the roles. So, hopefully, I mean, a lot of times data intensive systems are looked at as ways of labor saving or cost saving, but I really think we need to think of them as labor enhancements. And that means that we need to be working with people around how they do their jobs as well. So that's one of the elements of that. I think, I also think about on the education side, I'm mostly working with engineering students. And I think those of us in the methods fields have specific math, science, stats. We're so focused on getting people to do use a limited set of tools really, really well, that the kind of integrative learning that you need to be able to really create knowledge about what's good and what's not out in the world is often an afterthought or not done as systematically as it could be for the learners. So I think in that sense, I think we are a little bit still hit and miss in a lot of the methods fields in how we prepare students to take on data for good.
Thank you, Dharma. Thank you. Jamal, I'd like to ask you to speak, if possible, a little more specifically for this question in thinking about your statement that we're often not thinking about the data and how the data was produced, the logic behind how that data was produced. What does it take to do that? What are effective ways of preparing both the content experts as well as the technical experts on thinking about how the data was produced, and can we use data science, to do that? How should we be using data science and metadata to do that training or to add it into our processes?
Well, I guess I see it as part of a core competence of being a good data scientist is like being familiar with the data that you're working with, right? Now, of course, we've all been in situations where you have some data set, you're coming in, you're in a time crunch, you have to get something out. That's perfectly understandable, right? But I guess for me, right, like in urban planning, again, the census, in particular, the American Community Survey, is really one of like a primary data set that our students use all the time, not only in their coursework, but also in their actual employment. Um, and but a lot of our students really don't know like what goes into making the census. And for planners as a whole, we have like really sloppy practices around it. There's a great paper, 2018, from the Journal of American Planning Association, by Jason Jurjevich and some other some other authors that kind of highlight how practicing urban planners don't really have an understanding of like margin of error or statistical error for census estimates, right? And how that can actually like really distort our understanding of what's going on inside our cities, right? So part of that for me is like really trying to reiterate and focus upon for my students, like, hey, like you should be taking a look at the margin of error, right? Or, if your margin of error is larger than your estimate, like don't use it, right? And just these kind of like basic things to try and get them to be reminded that, oh yeah, like the census is a survey, these are the issues that are going on here, right? Like we kind of have these ongoing issues around undercounting and things like that. So that gives our students, I think, a better handle on some of the pitfalls of census data but while also still getting, I think, a pretty good foundation in actual census data analysis. And then I think on the other hand, it's like my mission as an instructor. I think especially being in a design school and having a lot of students who are designers who brag about going to college and not having to take like a math or a stats course, and then they come into planning school and they get blasted their first semester. I think part of this is a project of demystification, right? Um, Americans generally, uh, we are an enumerate society um, as a whole, and in particular, the public sector, due to like lower pay and things like that, does not necessarily attract people who have the most technical sophistication. But certainly in the planning space, I read a lot of plans, I read a lot of reports by cities. Cities will pay consultants tens of thousands, if not hundreds of thousands of dollars to produce some of these reports that have, empirical results in them. And you look at the reports and it's literally just repackaged census data. There's no reason whatsoever why staff planners can't do this kind of report, except for the fact that we don't teach it well. And that's on us as planning professors, right? So I really try and teach my students these techniques and approaches because as public stewards, they have to be able to like critically assess the claims of not only, like other people within the city, but like consultants who are being hired and coming in. And it's very easy for a consultant to come in and they show a graph or they show a regression table and they think they'll just intimidate everyone in the room. And, being able to explain to your students, like, no, you can do this also. And today in class, you're going to reproduce this report, I think gives them a lot of confidence that they can do this, but also to like real world exposure and experience such that, they aren't taken in by bullshit, frankly. And I think that's a huge responsibility on the part of public servants to be able to not be taken for a ride and to not be dazzled by someone mentioning coding or data science or something like that.
Jamal, Marsad, your statements were touching, especially about politics, right? You gave us all maybe a little wake up call that policies are often in place to allow people in power to stay in power. So we can collect all the data we want. But what can we actually do with that data? How do you think we deal with that in preparing practitioners and skills and competencies for practitioners? Is that a piece of truth that we give to practitioners? How do we accommodate for that?
Thanks for the question. Well, I often feel that we produce or graduate at the university professionals not societally responsible individuals. When you look at our curriculum, for example, at the University of North Carolina, our data science curriculum is organized around studios. So the cohort students go through the sequence of studios, starts with techniques, ends up with the final one that I teach, which is data science for social good. That's taught by two people, somebody from social science and the nerd, me, right? So we talk about the reason for doing it. Why are we doing? What value can we add to the society? What problem do we solve with data science? And then you go and look for data, then you try to interpret it, to massage it, see what techniques do you use, and so on. In the end, you actually tell the story. We have ethics now in all of data science classes, but why not in all of the computational classes, just like security and privacy? There's no one class on security and privacy. Every computer science class at the university has a computer privacy and security element in it. Why not ethics? Why not civic responsibility? We look at the companies, look at the analysts. They are given a specific task. There is an individual aspect of it. The societal, you're not evaluated based on your contribution to the greater good. It is a specific task that is crisply defined by the interest of your institution, of your organization. What I feel that it is missing is from our education, the element that talks about our value in the society, in our place in the society, the value that's expected of us to contribute to the society that in turn should then contribute to us.
Thank you. And Greg, last but definitely not least, if you could give us your response to effective ways of preparing practitioners, skills and competencies. And you mentioned, systematic exclusion of certain populations in STEM. So if it would be great if your answer could speak to how we do that better, and are there effective ways of preparing, including and preparing those practitioners?
Absolutely. And so, to that point, and also a little bit to, before I mentioned this sort of like meeting of the minds between like, domain experts and computational experts, I think what we're talking about here in all of this is, okay, well, there's that third path, right? Which is the person who is an expert in a domain and an expert in computation, right? And that's sort of where we're going here, right? So how do we sort of teach that joint set of skills, right? And certainly the social sciences have greater diversity and greater representation than STEM historically has, various STEM disciplines historically has. And so sort of infusing some of those with, infusing those social sciences like public policy, for example, with some of that education and technical skills can start to build that sort of central path. And is a sort of critical way to get folks engaged and sort of thinking in a sort of from a data perspective about the world in which they live, in which they inhabit, students. So, in terms of the skills question, right? So what are the most important skills? So, we could say things like, oh, well, you need to learn Python, you need to learn machine learning and data visualization and those kinds of things. And that's all sort of true. But actually, I think the most important skills, and over time, sort of having gone through many cohorts of students, both at NYU and at the University of Delaware, sort of training students in sort of policy disciplines, sort of to become that, to do that sort of practitioner kind of thing, to be data scientists, essentially, right? The three most important skills are sort of having a sense of adventure and a desire to figure things out, right? So like, what is this and why is this and how does it work? That sort of can drive questions, which those questions should be the things that are leading the data and not the other way around, right? The second one, which, I think that the phrase may have been originally coined, though I'm not sure about this, back in Berkeley a decade ago or something, is inferential thinking, and really sort of thinking, right? So like, given this, what would that imply about this over here? How can I use data to figure out what this means, or exclude that possibility, or like that method of sort of thinking through a problem, and then asking, okay, here's where I need to get. What data do I need to sort of get there? And what does this actually mean for the question that I have, right? That sort of like inferential thinking aspect is probably the most important skill. But really close to that is communication, right? So how to talk about this stuff. Because at the end of the day, you can learn technical skills and all of those kinds of things. But at the end of the day, you need to communicate with your team about what you've learned, right? You need to communicate with a policymaker about what it means, so that they can use that for sort of data-driven decision-making or informed evidence-based policy or something like that, right? You need to communicate with the public about what you know, those kinds of things. And most importantly, as you're going through the sort of data science process of figuring something out from data, you need to be able to communicate with yourself. You need to be able to say, okay, here's what I understand, here's what I need to understand. And so if I can sort of explain to myself what I think I'm seeing here, that can potentially lead me to a solution. So as we sort of infuse education in data science and public policy, for example, with things like technical skills in Python and machine learning and data visualization and so on, simultaneously infusing that with ways to think about these problems, and ways to use that to have discourse about these problems and get towards actually solving problems, right, is super duper important. And then obviously, as Mirsad said earlier, infusing the entire thing with ethics, education and data ethics is absolutely essential.
Thank you all so much for your very thoughtful responses. I think we're coming up on the last question.
Yeah, and I do want to note that we want to leave some time for audience questions. So I'm going to ask our panelists to please try to limit your answers to this last very big future-looking question, which is tough, to only 2 minutes. So 2 minutes each. And we'll go back to alphabetical order by last name so you can be ready. And the question is, how might research or projects in this area change over the next 5 to 10 years? So what is your vision for the future, especially given the rapid advances in technologies such as artificial intelligence? And so again, alphabetical by last name, we're going to start with Dharma.
Well, I'd like to echo some of the things that I think I already heard about what needs to happen. Right? We need to make sure that the future of data science as applied to social good is in the hands of people that are in love with the problem and are going to see the problem through, and in the hands of people that are accountable and have authentic relationships with the people that are represented in the data, and the communities and policymakers that are going to be relying on analysis. So that's my hope for how that goes forward. I think everybody's really excited about AI and excited about what that can do. And I just want to say that across the board, across every sector, the more people who have actually experience with AI and experience with these tools are far more circumspect about what they can actually achieve for us, in absence of all the other things that we've talked about today. So there's a little bit more sober, the more experience people have with these tools about what they can do. But I do think that there's still, I think there is a lot of opportunity for us, like around the things of like making the lives of everyday analysts better. But that takes an orientation of perspective that is not just shoving methods down people's throats or requiring people to collect data, and really partnering with people to use these in ways that are going to sustain and last and be comfortable for everyone involved. And I think at the end of the day, good science, it always starts, it's not tool driven, it's not tool led. So I think we need, as scientists, we need to take back that we don't start with AI, we don't start with the tool, we start with the research question. And the best place for us in applied research to what the questions that are the most important are the ones that actually matter for the communities that we're responsible to. And those are the ones that, that means that we're engaging on the front end with a lot of co-inquiry and co-discovery at the beginning before we start doing any science. And then we pick our methods, and then we pick our tools, and sometimes we're going to pick AI. But I think that really needs to be something that we need to be educating people who don't identify as scientists but are curious about those methods. I'll leave some time for other folks.
Absolutely. Thank you, Dharma. That's great. Greg?
Yeah, so I very much agree with Dharma. And in fact, I want just to highlight something that she had answered in an earlier question, right? If you look backwards, like 10 years, maybe a little bit, about 10 years or so ago, there was like this big thing that was like, just collect all of the data and then this will solve all of the problems, right? And so there was this like general sense of like, you gather the ocean or something, and that makes your fishing expedition easier, right? And so the but there was a transition away from that after a couple of years that was into problem first, right? It's that sort of that first, the foot that was forward was the problem foot, and then the data foot followed that, right? It was like, okay, well, and this is really where a lot of like the sort of data science process essentially sort of came to be. It's like, okay, well, what is our problem? What data do we need to solve that problem or address that problem? What analytical methods do we need to apply to that data to get towards that solution, and so on? And then what is the solution kind of thing, right? At the moment, we're very much in a holy smokes, look at all of the stuff that's going on with AI, look at all the amazing things it can do. Think about all the possibilities. Let's use this hammer on every single thing that may be generally nail-shaped or something like that, right? And so, but I also think, as Dharma articulated, that I think there will certainly be a transition from practitioners for sure, leading the charge away from that and more towards problem first, and then using new AI, trained machine learning models, aka AI, on some problem, or new methods on some problem. Then, but I don't want that to. I do think a lot of what's happening right now with machine learning and AI will transform society in fundamental ways all across the globe. But in terms of things like solving problems in sort of a data for social good way, I think that over the next few years, projects will sort of become as they've been, which is problem solving. Use what tool do I need to solve this problem?
I hope so. That's a good vision for the future. Jamal?
Yeah, I guess I'm on the more pessimistic end of things in terms of what I see in the near future. We're already kind of seeing now, which is we're going to have the production of a lot more garbage research, basically. We're already seeing in certain fields the flooding of LLM generated papers, and I use papers with like heavy sarcasm quotes there. I think we're going to have already kind of stressed journal systems be flooded by LLM generated garbage, basically. And I think it's going to be harder for us to be able to do our jobs, both in a pedagogical sense and also in a research sense, by just trying to be able to keep our heads above water, to be able to make it happen. Now, does this mean that we can't have good research or that these tools are bad? Absolutely not. But right now, all of the incentives are lined up around bad and dishonest actors. And there are a lot of institutional incentives, like the primacy of publish or perish or things like that, that really encourage researchers to take shortcuts. Um, and and ultimately, I think we all lose. So I'm actually quite pessimistic in terms of the kind of like published research space coming into the future, because there's going to be so much work trying to filter out the bad, um, the bad and the shallow, and frankly, the fictional. that's going to be coming in and masquerading as real research. Now, I happen to be in a small and relatively marginalized field of urban planning in the US. So I don't know if it'll be as big of a problem for us as opposed to y'all on some of the larger, more applied fields, particularly in policy. But certainly this is already becoming an issue, in areas of in areas of computer science and in some of the natural and physical sciences. So I think it's just a matter of time before it starts to bleed into the greater social sciences also.
Yeah, we absolutely have our work cut out for us. Mirsad, what are your thoughts on the future?
Okay, very quickly, when you look at the levels of capability and capacity today, companies seem to be having more of that than anybody else. Google, Amazon, Bank of America. They know more about the society. They have more resources than even the government. The government comes next. Who comes the last or next in that hierarchy? It's the universities. Is that the way to the future? I'm not sure that that's the best of division of resources from the societal point of view. We have to find a way to collaborate. It's very hard to get data from anybody. So speaking of universities, companies will not give it to you. Some of them will actually sell it to you. I'm thinking about reorganizing education, convincing private sector and government of importance of supporting education even today because it seems to be in decline. Data science and AI should be significantly expanded throughout the curriculum everywhere. We are now getting to the point that we are changing what it is that we need to learn in our time in school, in college, and how we learn about it. Data with everybody produces data, everybody analyzes data, every discipline, and the ethics element of it, but also the resources to be able to process it. What companies can do now, even governments cannot afford. What's the place of universities in those times? That's the question for me.
Definitely time of change. Esteban, let's take us home.
I'll try to reflect in a sense, maybe a balanced perspective in that in some ways, especially in the short term, I think I share some of the pessimism in terms of, in some ways, we're almost making, whether it's data science or research or pieces of this process so easy that anyone could do it, but that doesn't mean that it's being done well. And so that's one thing that we have to be keenly aware of. On the other hand, I do think that there is something to let's say human ingenuity, right? And so we create a lot of problems for ourselves in the process of making one part better. We make other things much worse, and we're sort of going through this process repeatedly in some ways. And so I think when I try to take a step back, I do see that there's a bigger picture and that there are people thinking really carefully about these elements, right, and trying to provide leadership. And so I see a lot of challenges, but I also see that there are some really interesting opportunities. Not to get overly technical, but I definitely am still sort of in awe sometimes when we think about Earth observation, right, and the sheer both quantity but quality of data that suddenly is at our fingertips that I think can be leveraged for so much good, right? And that's something that even 5 years ago, I probably would have been like, no, that's not happening. So of course, the incentives and the institutions and all these things around them will matter just as much, if not more, than the methods themselves and the sort of technical innovations. But to me, I think we have sort of this sort of there is a balanced path should we choose to take it, let's say. And so I put that, not just in my hands, but or the others panelists and speakers. I think it's in all of our hands, right? It's our responsibility to be stewards of whether it's data or data science or how we use these things to do good.
I love that. We are the frontier, right? We have the responsibility. We now have some time for questions. I don't know if there's a hand raise feature So, oh, we got some coming in on the chat. So let's just go with that. If you have a question, why don't you drop it in the chat? Because otherwise we might start talking over each other. And I'll just go ahead and field this first one from Lauren. And you all should be able to see it. When given the opportunity to advise on policy, are there guidelines on balancing effect size, statistical significance, and downside risk of a policy? And I'll say just any of the panelists who would like to unmute and take that question, please go for it.
I can jump in here and say something. Maybe, I don't know.
Great,
We'll see.
thank you.
Speaking from my own experience, when talking to when talking to folks who are decision makers, who are policy makers, and who are looking to an external person as an external analyst type person. That was part of a sort of public academic sector partnership on, what is this data telling us about the problem that we had, kind of thing, right? I will say that it is imperative, difficult, but imperative to be honest with oneself and honest with the policymakers that you're talking to about what you know, about what the data does say, right? So being able to articulate your assumptions that go into an analysis, being able to articulate uncertainties in your analysis, being able to articulate ways in which your model, your specific model, may be inappropriate or maybe ill-suited to a particular type of question that a policymaker might have, whereas other models might be more suited that you haven't done yet or something like that, right? So having those kinds of conversations, again, to go back to the communication thing I was talking about before, being able to communicate those kinds of sort of technical aspects of what you're doing to a person who doesn't have a background in this, but is about to make a decision that affects the lives of many, many, many people, is high stakes. And so I would certainly say that it's really crucial to be able to learn how to talk about these kinds of things with people who don't have a background in them, to be cognizant of your own biases that go into stuff. Understanding that you'll never be able to fully articulate, even to yourself, your own biases, but to constantly be vigilant for that. And to sort of not overpromise. So like very little interpretation, lot of this is literally what the data says, right? Very little of, and this is what it means. Because how to use that, like if you say this is what the data says under these assumptions, then that is correct. Then taking that and turning it into your own opinion about something gets to a different sort of matter that starts to impart your own sort of moral and ethical judgment on things, where if you're advising a policymaker, that's up to them in a way, right? And so, yeah, I hope that answered the question at least a little bit, but really that communication aspect and learning how to communicate about these kinds of things is really important.
Any of the other panelists want to add to that before we move to the next question? Okay, I'll read the next one. Ethics was mentioned as a critical factor in data science training. What are some ways of effectively integrating ethics throughout curriculum for students and/or training programs for practitioners? Oh, Dharma,
Yeah.
do you want to answer that one?
Pick me. I love this question. I love thinking about this, and everyone else. I love you if you also think about this. So I think in the methods fields, this is something that, again, has been pretty inconsistent in the past. So there's lots of room for growth here and lots of things to try, but a lot of things that already work. In addition to having the data and society classes where you're doing the big picture thing, I think it's so important that we're thinking about ethics at every step in the process of producing science. and helping people to do that and normalizing that. So I encourage people to be asking questions, little ethics questions and conversation, and normalizing a culture where we're talking about, you know, what can go sideways, what makes us feel uncomfortable. I placed a lot of value, and I've seen it be very transformative in the teams that we work with, just giving people permission and space to talk about the concerns that they have as they're occurring. And I think we can do a lot of institutional and cultural changes is possible if we just make that normative change.
That's great. Thank you. Mirsad, I saw you on mute. Do you want to add?
Yeah, very quickly, as part of our data science degree, every class has a project. Every project has several phases from data collection on, and 10 methods, analytical machine learning methods suggested. Every one of them has a question on ethical aspects of it. So data selection, how does the algorithm actually work, what are the ethical implications, and so on, and we grade it. So it is specifically, explicitly defined in the instructions to the students that without that, thinking about it, demonstrating that you understood it and what consequences it had, you will not achieve perhaps the best grade that you wanted.
Great, thank you. I'm going to move on to the next question, try to get through as many as we can before the end. When you get a project, how do you choose what statistical methods and what variables to include to help your client the best?
I'm happy to jump in on that one. It's definitely part of the nature of the work that I do. And before we get into methods, actually, what we often do is really try and understand the logic of what is the program, what is the policy, what is it that you're trying to affect in some way. And so there are lots of different ways to do that. Log frames or theories of change or things of that sort are just very common foundational ways to do that. But I think they're actually crucial because in that process, you also usually clarify what the question is. So if you want me to, help assess a program and understand what took place, as opposed to why it took place or how it took place, right, those might actually be entirely different. Let's say whether they're data science or just more generally research exercises or investigations. That could include both, from knowing that I want to crowdsource is some version of big data to do sentiment analysis because that's going to give us the let's say best overall picture on how people feel about something, to actually we really need to do in-depth interviews with a policymaker, right? And that's not necessarily thought of as something that maybe goes into data science or that's quantitative, but there's a lot of very rich qualitative or mixed methods work that we do sometimes that is really combining the sort of the cutting edge quant work with in a sense a deeper perspective, and so then from then it really is just about what is the question and what is the data that's available, right? So with that in mind, we can really sort of form a conceptualization of what the data generation process is in the real world and which parts of that can we actually observe and detect something from, and then that's going to sort of take us to that last step, which is ideally we've decided on a lot of these different pieces, and what are the variables that are important in theory, what are some confounders that we even if they might not be thought of as important in theory given the history of this program, that we want to make sure we account for, right? And you can certainly use sophisticated methods starting from lasso to far more I think complex ones to kind of do that in a data driven way, but you also might have reasons to anchor on something that are valid. So really, it's quite a balance, but I think a lot of it comes down to understanding programs and understanding what is the actual question, which you can pose many different ways, and sort of what is the thing that your client or that you as a researcher want to learn or get out of things, and that really leads you in different directions. The nice thing I would say, just in my position, is that I work with a lot of interdisciplinary, multidisciplinary people. And so when I realize that maybe the right way to do something is not in my toolbox, it's relatively easily for me to reach out to someone else. And that's not necessarily always the case. That's quite difficult, right? We all sort of have a finite toolbox, even if we're continuing to develop it. And that's something that is, I think, an ongoing challenge for everyone when it comes to sort of deciding how am I going to do this analysis.
Thank you, Esteban. And I hate to stop the conversation here. There's so many great thoughts and everyone is sharing so nicely, but we are running up on time. So I want to turn it over to Francis, if that's okay, to wrap us up and bring us home. And again, thank you all for joining.
I put it in the chat. Thank you to everyone for joining and staying with us. And feel free, I guess, to continue the conversation in however we can on your public social media platforms and in continuing your work and building your network with the panelists and people that were here in the audience. We hope to see you at an APPAM or ASDA event, either virtually or in person in the future. Take care. Thank
Thank you,
you.
everyone. Take care.
Thank you.
Well,